Good morning. I hope you're doing well. I'm doing very, very well. I've had a very busy last week, but like the best kind of busy. And yeah, I'm very keen to show you what I've come up with. It's coming together. We're getting there. I have there's a lot of things to talk about. But yeah, we'll get there when we get there. Cool. So, first thing, super exciting. We're getting Mocap. This is a very, very big milestone. I don't know if you can really call it a milestone if it's just something that I need to buy, but it's a very important part of the project in my opinion, and this is going to open up so many things. And I've said this a lot, but one of the things that it will open up is being able to do partner juggling. So if Jugglebot can see the balls, and I can see the balls because I've got eyes, then we can work together and juggle the same balls. So that's one of the things that I am most keen for when the Mocap comes, and this is one of the things that this is a big reason why I want to get my code up to scratch before the Mocap arrives, so that I can just like jump in, and after I'm sure a bit of teething pains, because it always is, yeah, get like partner juggling working. And I feel pretty good about it, to be honest. I reckon we could maybe do 5 balls between the two of us, which is very strange. Like I've done partner juggling with like another human, obviously, with 3 balls, and there's many different ways you can do that, like facing each other or standing side by side. But I've never tried 5 balls, and I think it will be very interesting. It's gonna be kind of weird. I'm gonna have to like kneel on the ground, I think, but yeah, I'm super keen for that. It's gonna be a lot of fun. First robotic/human partner juggling, as far as I'm aware. There is the Disney research one, but that, I don't know, it's kind of clunky. Definitely can't do 5. Definitely can't do 5. And maybe it can help me practice 7 as well, although we might have to go outside for that. Maybe asking a bit much. So, you might be curious. I was doing a lot of deliberation between 2 different types of Mocap, and one that I finally ended up on is the Miqus M3s. Let me get rid of me. And yeah, so these are our specs that we're going to be working with. I'm going to have 4 of these cameras, and they should have a pretty good view of Jugglebot, so we should have a fairly, like, we should be able to track everything to this level of precision, which is nuts. 0.11 millimeters. That's going to be so good. It's going to be so good. I'm extremely excited. Yeah. And so we've got about approximately, I asked for a very rough delivery estimate, so this could be like plus or minus, probably plus like a little bit, but they said it should be around, like should be here by around the end of November. So we've got about 6 weeks to polish the code and get it all up to scratch. So I think that should be enough time, I reckon. This is going to be so good. I'm so keen. One thing that I should have had this open, but I've moved things around, is that I'm keen to, I'm keen to, for one, have the Russian juggling balls that I mentioned a couple of weeks ago. I've ordered them and they're on their way, but because they're coming from Europe, like they're going to be here in a little while. And one thing that I will need to do for these balls, or for any balls to be seen by the tracking system, is that they will need to be very reflective, essentially. And in my mind, there's 2 ways of doing this. I can either use the little tiny retroreflective markers that I've also bought, that are like little spheres that you usually stick on things, and then you can track those things based on where those spheres are. And so we could make like a 3D printed structure around one of those spheres, potentially, but that sphere would have to be like bang on in the middle, or have a bunch of spheres around the ball, but of course that's going to make it tricky to catch and manipulate. So the other option is to just cover the ball in this retroreflective tape. And I've been doing a little bit of searching around, and it turns out you can actually buy this retroreflective tape in different colors, which kind of makes sense because they use it on trucks for like this sort of thing. And yeah, so we could even have retroreflective balls that are actually colored to make it more appealing to the human viewers, which would be pretty cool. Yeah. And one thing that I've been thinking about is a big goal that I kind of like need to get to eventually, is to have Jugglebot juggling. I've talked about this a lot, juggling LED balls, or like colored balls. And someone mentioned this, I think it might have been in the last stream or the one before, but I think this idea is becoming more and more possible, where we can have retroreflective balls, and somewhere like behind the audience, or like in front of the juggling robots, because there'll probably be a few by this point, there can be like lights that are projected onto the balls, and because they're retroreflective, they'll just like shoot the light back out in whatever direction it came, or just like around in general, I'm going to guess, because it's a sphere. And so we could potentially color the balls that way, which would be it's a completely different approach. So I've always been just imagining that I'm going to have to go through some process of like designing the balls myself, because no one makes what I want these balls to do in terms of like syncing up with each other, syncing up with the robots, being able to like change the colors on a dime, charging them wirelessly. I'm not going to fuck around with like cabling, charging like 100 balls. It's not going to work. But potentially we could remove all of those problems by just having super reflective balls and like lights that color them. And we'll obviously have to like move around. But if the background is like really like obviously Vanta black is quite expensive, but if it was some sort of like very non-reflective black background, then as long as the projected light is larger than the ball, it should be fine to color it. I don't know, just a thought, something to think about. But yeah, I'm super keen. This is going to be great. Cool. All right. On to, actually, there's one more little update, which you may have seen hints of last week, which is these screens above me. And I am not going to be able to take the microphone with me, so you're just going to have to watch me while I do them. They're so good. It's so clean. And we've also got white. It's very cool. I think that white one might still be going down. I think we're good. Yeah, super cool. I don't know, that background is always like, I really want to keep this space like open so that I can access the tools really easily. But having Jugglebot's normally sitting right in front of that, and having the camera on that with like that really busy background, it's so hard to actually focus on what's actually going on. But now we should be able to put Jugglebot there. I need to move cameras and stuff around to actually show you what these shots will look like. But in principle, we can get a nice clean, either white or black background. It's going to be much nicer for filming different shots later on. Yep, cool. All right, so now on to the actual updates for this week. So we noticed last week in my demo that I showed you that the heartbeat registry is super slow. So for context here, the heartbeats are broadcast by each O drive, and these heartbeats just contain information basically saying like, I am alive and I have no errors. Essentially, there's like, yeah, that's more or less it. It's I think a heartbeat is a very good term for it, and this just gets like pulsed out every now and then. And because all of the, I think it's like once, I think I've set it to like 10 times per second, I think, but you can change that. And yeah, so because all of the O drives turn on at pretty much the exact same time, they all send this pulse out at pretty much the exact same time. And I want to confirm that all of these heartbeats have been received with no errors before we advance the state machine through the next steps. Because before, the way that I was doing this is I would just check for any heartbeat, and I would say, yeah, if we've received any of them, then we've probably received all of them, so it's fine, we can just keep going. But that's not a really robust approach, and like if there's any cabling issues that come up at any point, or anything goes wrong that might disconnect a single O drive, or like maybe I've been doing some work and I've forgotten to plug one of them back in or something like that, this way we'll actually have to check that all of them are there before we start actually getting the robot to move around. Yes, they're broadcasted around the same time, and I've verified that publishing is working. So I've got basically a pipeline where those heartbeats are published by the O drives. They come into like the ROS network, and then they get published through the ROS network so that everything can see them. We don't need everything to see it, but everything can if it wants to. I've also throttled that so that we don't have too much messaging going on over the network. And if you're curious, that's how I've been throttling it. Yes, so the publishing works. All of those messages come out as we expect, but the subscriber, which is this standby state, which is like the state in the state machine, consistently misses some messages. And this is what happened last week when I was showing off what happened. I started it up and we just had to wait. We just had to sit there, twiddle our thumbs, and wait around until eventually it decided to catch up to all 7 of the heartbeats, which is very frustrating because like the amount of time that you had to wait was anywhere from 0, because it would just happen like instantly, which is what it should do, up to like maybe like 20 or 30 seconds. And like it's so frustrating when that happens. I'm just like sitting there being like, can I do anything to help? Like just waiting. It was really weird. So what I tried doing, I've tried a few things. one of them is changing the quality of service parameters. So this is a way in ROS to set how important each message is, because the network can't have a memory of all of the messages that have ever been sent over the entire course of that session, because that's just too many messages. So you can set these quality of service parameters to basically say, this message is not that important. If you miss one or two, it's fine, as long as you keep getting the new ones. Or you can say, actually, I really want you to receive and process every single message before progressing to the next one, even if that means that's going to slow you down a little bit. You can fiddle around with all this sort of stuff. And yeah, so I tried changing it to all of these. I tried a bunch of different things in the durability, history, and reliability policies, but this seemed like it should have been the most robust combination, but it didn't work. And I want to note something important here, is that I don't want to store all of these messages over time. So one option here would be to basically receive the heartbeat messages and just amass a log of all of them, even though we're not keeping all of the, we're definitely not going to be keeping all of the messages of every message in the entire network, but these heartbeat messages aren't broadcast that often, so maybe we could just retain all of the heartbeat messages, and that way the node can kind of cycle through them as it needs to. But I don't want to do that, because if I have to reboot the system, or I hit the e-stop or something, I don't want the system to then be catching up on the old messages when it should be focusing on the fresh new ones. So I don't want to store all of them. So I believe that this whole problem is caused by each message being processed one at a time. And this processing time is long enough for subsequent messages to be skipped. So if 7 heartbeat messages all come in at the exact same time, more or less, then it might process the first one, and the third one, and the fifth one, for example. It'll skip the odd ones. It's super, super hard to know what order it's receiving them and skipping them, but it reliably skips some of them, which is very frustrating. Yes, so I tried going into the state, so we actually have, here we go. So this is my state, my standby state. If the text is too small, you want it to be bigger, just let me know. So I tried going into this monitor state, which is part of the YASMIN library, which the code is in the description for as well. And so this is the generic, if you ever have a state that listens to a topic, this is what you use. And so I tried going into here and basically saying, I found this. Where is it? There's a point where it sleeps. And it just says, let's find it. Here we go. Time.sleep, self-time to wait. And I'm okay, it's clearly waiting for something. So I'm just going to delete that and just see what happens. Let's stop it waiting and just make it go all the time. That didn't work. There's also this monitoring thing, so that way the state is just idle when it's not the current state, so that when you move off to a different state, this one is not really running anymore. I tried deleting that as well. Didn't work. I tried a bunch of things and it just didn't work. But I eventually came up with a solution, which kind of feels sketchy to me, but it works. So it's good, I guess. And my solution is that in here, I've got my standby state, which is the name of the state that's listening to a topic. And the way that this is supposed to work is that you listen to this topic, and then as messages are received, you go to the relevant callback function, and then you can process the data and do whatever you want, and then return some, you can either cycle back through and continue in the same state, or you can say, okay, cool, I've received the message that I need to, and let's move on to the next state. Importantly, if you use this pipeline that they're suggested that it's set up to do, so you have this topic that it's subscribed to and you have this callback function, very, very usefully, that callback function has access to the blackboard. And this blackboard is what stores all of the information of what is going on in the state machine. So you can have I'm using the blackboard right now to keep a record of has homing been completed? Has the encoder search been completed? Has leveling been done? All of this information that's kind of a level above or below, depending on how you want to think about it, the rest of the states. And so I'm recording all this information in the blackboard. And you have access to that blackboard if you use the correct process. But if we use this correct process, then we go through this time.sleep bullshit and it doesn't process all the messages properly. So my solution is to have I'll show you on the PowerPoint actually. This might be, I'll go through it on the code as well afterwards. I'm getting warm. So my solution is to have the monitor state, rather than subscribing to the actual topic that I wanted to, which is the heartbeat one, instead it subscribes to just some random dummy topic that's only used for this purpose. And then in the init, I'll go through the code, yeah. So this stuff is all just for like a dummy message. I've still got all of this reliability stuff here just in case I want to go back eventually, but I probably won't. I'll probably delete that soon. Where we're actually getting the heartbeat information from is here. We're setting up a different subscription to the actual heartbeat topic to actually process these heartbeat messages. Now, annoyingly, I don't know of a way to have this subscription have access to the Blackboard. So now whatever I'm subscribing to here is just like within the state machine. It can't actually access the rest of the stuff. So it only exists within the state. As far as I'm aware, I can't think of a way to have that access the information in the rest of the state machine in the Blackboard, which is kind of annoying. So I've got this little subscription that goes to its own callback, and this here we process all of the heartbeats, and this works like super quickly as I would expect it to. And then once it's processed once we've received all of the heartbeats, we say, yep, we've got them all. And then we publish to the dummy, topic, which is then received by the same state. And it says, yep, cool, I've received all the heartbeats, or there's been some error and we need to abort. And this seems to work. So it's a little bit sketchy, but it seems to do the job. And yeah, it would be great if there was some way to have this not be true. If I could like give the subscription that's like in init access to the Blackboard, that would be very, very nice, because then I could update like which heartbeats have been received on the Blackboard. And like, I imagine I'm going to be using the same sort of structure later on. And yeah, I don't know. If anyone's got any ideas for that, I'm all ears. It's a very esoteric problem, but yeah, this seems to get around it. My biggest grievance is that this introduces a new topic, and I want to kind of like minimize the number of topics that I've got on my ROS network. The silver lining, at least, is that this won't be publishing all the time, so it probably won't create that much overhead. I don't know. Yeah, cool. Okay, moving on. So, one thing that is being strange is that the general like process through here, and I'll show you a demo in a sec of what all this looks like, and I'm very keen. It's so good. I love it. But the general process is we boot up and we see. I don't want to give you too many spoilers for what's to come, but yeah. So we boot up. If we need to go through the whole like homing process, we'll run through the encoder search and then run through homing, and then we'll be idle, and then we can just sit there, and then depending on what I want the robot to do after that, I can decide, and it will go off and do that once I write that code. But it has to go through encoder search first and then homing. And this encoder search is very important because otherwise the O drives can't control the motors. If the O drives don't know where the motors are in terms of like their rotation, then we have no hope of controlling them. So this, yeah, it has to run at least once, like when the O drives turn on, and yeah, it's very important. It's also in CAN interface if you want to check it out. And occasionally it doesn't run correctly, and I have no idea why. It's very strange. Whenever I add logs, it's been running fine. I've run this, I probably just need to sit down and run it like 100 times and then see how many times it's stuffed up and like add more logs throughout. But it seems it's very rare. It's just like maybe it's happened maybe 3 times out of like the 40 or 50 times that I've gone through the same process. It just doesn't run. Yeah, I think what's happening is that it's just not putting the O drives into the run encoder search mode. So they've got this, the way that this signal is being sent out is basically like, it's a CAN signal where I say all O drives, or like one at a time, but it's sent out at pretty much the same time, enter your run encoder search mode. And then they'll say, yep, cool. And then they enter that mode. Oh, my background's slowly coming down. I need to adjust that. Yeah, then they enter that mode, and then they say, I can't do anything else right now. I'm in this mode. And then once they finish, they say, yep, I'm done with this mode. I have like reached I've like found my encoder index pulse. But I think what's happening is that it's just not entering that mode at all. So I think what it's doing is it's saying like, I'm trying to send the signal to enter that mode, and then the signal sends out as far as I'm aware, but I don't think it's actually being received properly. I think. And then I need to improve my error handling here a little bit, but I've set it up right now where as soon as the signal goes out, I basically say, yep, cool, it finished, it was a success, it was good, without actually verifying that that is the case, which I should probably fix that. But then it goes straight into homing, and as soon as it starts to try to home, it can't home because the O drives don't know where the motors are, and so they can't run them, and it just stalls, basically. It's very weird. So I'm thinking I could potentially add a check to ensure that all of the O drives have actually entered that state, because if they haven't, then the system hasn't run properly. But the problem is, sometimes the index search is really, really fast. Like if I've just run the index search and it hasn't homed yet, then all of the O drives will be, or all of the motors will be at that index pulse because of the last time that it ran the index pulse. And so it doesn't really need to run. It just like, it runs it for like a split second and says, yep, we're at the index pulse, that was quick. And then it continues on to the rest of the stuff. So my worry is that if I set up this check, well, yeah, my worry is that the only ways that I can think of setting up this check involve checking that all of the O drives are in that state, and then check that they've actually found the index pulse. But the problem is that sometimes the index, because it's so fast, one of the O drives might actually finish its search before the other ones have even entered that state in the first place. So I'm not really sure how to set this up. Yeah, in saying this now, I've come up with an idea that might work. So to give full detail on what I'm thinking, the O drives also have, part of their heartbeat message is actually like a trajectory done message, or like a confirmation. And that way, if once they're finished with whatever you last told them to do, they say, yep, I'm finished, I'm waiting here, I'm just sitting here doing nothing. So maybe I could actually use that that trajectory done check to see if they're finished. So I can check if all of them have entered the index search at some point, and then after that check if the trajectory is done for all of them, because that will still be done even like seconds after they finished. That might work. I'll have to try it out. Anyway, next thing is that Jugglebot has a memory. So this leads to, or relates to something I said last week, which is actually incorrect, which was that I said that homing needs to be run every single round, every single time I turn Jugglebot on. But that's actually not true. So the reason it's not true is because the O Drive Pros are being powered by a 12 volt bus, which is like the CAN bus, but the motors themselves are being powered by like a 45 volt bus. And that's what I turn on and off when I hit the E-stop. So the O drive, when I hit the E-stop, the O drives still stay on, but the motors turn off because they won't have power anymore. And because the O drives stay on, they can still track where the motors are. So like if I have the power off and the O drives have like gone through their homing sequence, then I can move the platform around and we can see what position all of the legs are at, even though the motors aren't getting power. And this means that the O drives, well, one of the carry-on effects of this is that the O drives remember what their homing was and like where they are set to and where their position is. And I haven't been utilizing this at all so far. So up until now, every single time I boot the session up, even though the O drives know exactly where they are, I still get them to go through the index pulse search and through the homing sequence, and then they presumably just end up like exactly the same spot that they were at before. But I've been doing that every single time, and I don't need to because they have a memory. They remember where they were. Now, the reason I haven't been using this is because I haven't known how to implement any sort of memory. But I've been having a lot of thinking about this, and what I've come up with is that the Teensy that's on the platform is also powered by that same 12 volt bus. So whenever the O drives have power, that Teensy has power. Whenever the O drives lose power, that Teensy loses power, assuming I'm not plugged into it over USB. Which is something I haven't yet stuffed up because I have it connected over USB because I've been changing its code. But it's possible that if I unplug the O drives and I don't unplug the Teensy, then the Teensy will remember things that the O drives don't, which is the only potential downfall of this system that I can think of. But as long as I don't have it plugged in, which is normal operation, then it's whenever the O drives have power, the teensy has power. So if the teensy has a memory of homing being done and the encoder search being done, then that means that the O drives will also have that same memory. What they are remembering is obviously different. The O drives are just remembering what happened for its individual axis, and the teensy is just remembering, yep, homing in general has been complete, but it's like about the same thing. So yeah, so this is what I've done. I've implemented a memory, and this is so nice. This means that I only need to run through that encoder search process once, and then I can e-stop, I can close the ROS network, I can do whatever I want as long as I leave the CAN bus connected, and I won't need to go through that process again. I can just boot up and we'll be straight into like being able to move around, which is super cool. Unfortunately, I haven't, or for better or worse, I haven't actually gotten around to implementing any of the code that actually controls the robot. So for the last week, the robot's been going through encoder search, home, off. Encoder search, home, off. Sometimes it'll just be like on and just like skip right to the end, but it's just been encoder searching and like homing for like the last week. But in theory, once I do get the moving around code working, then I shouldn't need to do the encoder search or the home if I've already done it before. And this will of course be the same for the leveling. And I'm hoping that we can save those leveling numbers. So like if the auto leveling has been complete and we've figured out or measured that we need an offset of like 0.1 degrees in the X direction and 0.2 degrees or whatever in the Y direction, I'm hoping that we can save that information, and that way on subsequent boots or like runs of the session, we won't need to go through that auto leveling process and it will still be valid. I'm unsure of how well that will work because I don't actually know what's causing it to be not level. So part of me is worried that we may need to do auto leveling every single time just because small things might change, but we'll have to see. Yeah, cool. Demo time. Let's have a look. Cool. So yeah, because the robot isn't doing anything exciting, I don't have any camera set up to watch it. It's just going to home and do not much else. But we can watch the state machine, which is where all the fun stuff is happening. And we can watch the GUI as well. Let's try this. Yeah, that kind of works. I'll put me up here. This GUI, the actual 3D viewer isn't really going to do anything, so I'm fine to block it. All right, so this is not a clean session. Let me re-upload the code to the teensy. So now the teensy is fresh, and so this is emulating if I just booted everything up, I just plugged in the CAN cable, everything is completely fresh. Just gonna wait for a sec for that to upload. And turn the power on. Come on. There we go. All right. So now I can boot up the system. We should have so we're in standby. All of our heartbeats have been received. We go through the encoder search. We're now homing, and now it's idle. And all of that was logged in the teensy. So now we have a record of all of these things having been done. So you will note, I also discovered in preparation for this stream that I can actually click on individual nodes, which is pretty cool. You will note that the standby it was chilling in standby for like a second or two, but I think that's just because the heartbeats, I've got a 1 second interval on when the heartbeats publish, because I don't want the heartbeat messages just like spamming my ROS network. So there's a worst case scenario, we'll have to wait. I think it's either 1 second or it might still be 5 seconds from when I was doing some debugging, but we'll have to wait some amount of time for that to happen. But they all get processed in one quick hit, and we can actually, I should have refreshed this. Yeah, we should be able to see in here, if I had refreshed it beforehand, all of those messages saying like, we've got all of these heartbeats and they're all like back to back to back to back, which is great. And then yeah, so once the heartbeats have been received, we go into encoder search, we go into homing, and then we go into idle. And you will note that there's a new node here that wasn't there last week, which is boot. And boot is a very important node because it allows us to do stuff like this, where I can close down the network and our state machine goes away. I can leave the power on or off, it doesn't matter, that's just powering the motors. And then if I boot up again, now this is not going to do what I want it to do, but you'll see it went from boot into standby, into encoder search, into homing, into idle. So it starts off on boot, and in boot it checks, it polls the teensy and says, "Hey teensy, what do you remember about our last state?" And the teensy says, "I remember we've already done encoder search, or we've already done homing," or like however far we've gotten through in the last session, or like in previous sessions. It relays that information to the state machine, and it did, and I'll explain this in a second. It should be able to go, "Oh, we've already done the encoder search and we've already homed, so we can just go straight to idle. We don't need to go through the encoder search or homing, those are already finished. We can just go straight from boot to idle." And that works, except in the last like 8 hours, I've done something screwy in my code. I only did this first demo like 20 minutes before the stream started, so I haven't had enough time to figure out what I changed, but I changed something stupid, and now I can see the encoder search is not being remembered. Let me show you for proof that I'm not lying. How can I make this bigger? So I turned the teensy on. This is like all information from the teensy. First one. Oop, encoder search is complete. So this is the first run that we did. It finished the encoder search, and then it finished the homing. But for some reason, when it homes, it gets rid of the encoder search number now. It didn't do this before. And so it overwrites it, which is very annoying. Yeah, I don't know why. I've done something stupid, and I'm just like overriding the encoder search value. So just then, when I turned the system back on, the teensy said, "Hey, we've finished homing, but we haven't finished the encoder search," which really probably should raise a flag in the system being like, "Hang on, that shouldn't be possible." But once I fix this bug, that shouldn't happen again. I don't know. Is that worth putting an error check in for? Maybe. I don't know. And of course, I still need to add a branch between idle and fault, and I will of course do that. But I'll talk about what I need to do before that in a sec. But a really cool thing that I really like is that now it actually handles errors much better. So now I can hit the e-stop. The robot it was in idle, it was chilling out, but now it's gone, "Hang on, like something's gone wrong. Was the e-stop hit? Maybe it was." Smart robot. And we've got all these errors coming straight from the CAN bus. And these are on a timer, so they can't just spam the bus all the time. But yeah, we get every 5 seconds we're seeing, "Ooh, we have these errors. This is not good." And really, this should be sending us from idle into fault. But you can see I don't have a branch between idle and fault, yet. But I will do that soon. But the cool thing is that I can turn the power back on, and the errors go away. And the system realizes, "Hoo-hoo, there's no more error. We have nothing, no error to report." So once I do add this branch between idle and fault, what I'm thinking is that in fault, it will just sit there listening to this topic that's publishing these errors. And then once it receives, "Yep, there's no more errors, we're all clear, we're good to go again," it will head probably back into boot, and then from boot, wherever it goes to from there, presumably straight to idle, depending on whether I've unplugged things or done whatever else. So good. Of course, there are a couple little niggles in here that I need to fix up, but like the general principle is it's coming along. I'm a big fan of this. For this might seem like a trivial thing. It's like, "Oh, cool, you can turn the power off and turn it back on, and it doesn't completely shit itself." It's like, wow, this might seem like a nothing thing, but it's not, because in the past, every time I e-stopped, it would just like crash the ROS. It wouldn't crash it, but like it would effectively turn the ROS network off and would say, "No, nothing's going to happen again until you close the ROS session down, fix up whatever caused you to do the e-stop, turn the power back on, and then start the ROS session again." Which then, of course, because I was a muppet before, would then have to go through the encoder search and the homing and the auto leveling again. And that was a pain in the butt. I want to be able to just like e-stop for something trivial happens that's like, something's going to bit out of hand. I can just e-stop. It will shut down what it's doing. Well, the modules will stop receiving power. It will go into fault. I can fix up whatever the problem is, turn the power back on, and we're good to go again. I won't need to touch the ROS network at all. We can just keep the whole thing running. So good. All right, let me talk about other things. I don't need that anymore. Cool. So, yeah, all right, I'll talk about this. Cool. So all of this information is being published to robot state. And let me show you what robot state actually is so that we're on the same page. This is my robot state message. We have a couple things on here. We've got, is the encoder search complete? Let me move my camera out of the way. There. Yep. Is the encoder search complete? Has this been done? Is homing done? Is leveling complete? I haven't actually implemented any of the, re-implemented any of the leveling code yet. I'm trying to focus on like getting this core set of nodes working like really, really well before I expand out. But I don't know, future-proofing, I guess. Adding the leveling in. Now this is an annoying thing. I don't really want to talk about these pose. I'll talk about this pose offset stuff later. If you're interested, post on Zulip. I don't want to go through it right now. But we basically have like a status of like what has happened so far and are there any errors? But my question is, I don't know what nodes should be able, or what states rather should, well, what states and nodes, whatever combination, should be allowed to publish to this topic. My thinking is that only the state machine itself should be allowed to send these updates. What I don't want to have happen is just like the Wild West where everyone can publish, all of the different ROS nodes can publish to this topic and say, I think we're in this state. And this other node says, I think we're in this state. And that's going to get super confusing really quickly. So my thinking is that by having only the state machine itself publishing this information, that will kind of tidy things up and make it really clean. But there's a problem because the hardware errors will propagate from the CAN handler up through the system. They won't be received by the state machine. So my thinking is that maybe we can have the state machine handles all of the like higher level stuff, but other nodes right now only can handle it because that's the only one that actually interfaces with the hardware, but there might be other places where nodes will receive the errors first, and these nodes can publish errors to this topic. So only the state machine can publish useful information, well, like state information, but then every other node, well, maybe not all of them, but like whichever ones need to, can publish only errors. And that way there's no possibility of nodes disagreeing about what's going on. There is a possibility that different nodes could disagree about what errors there are, but like, I think that's not too bad at the end of the day, because like if an error is there, an error is there, you know? But yeah, this is my thinking. Okay, yes. So this is where we're up to now. I would love feedback if anyone has any suggestions on that. I feel like the Wild West seems super chaotic and I don't really like that, but there might be cases where it's useful for different nodes to publish state information. I don't know. All right, I need a drink of water and let me read this comment. Let's go on me. You can watch me drink. So Ransombot says there's retroreflective glass paint for highways and stuff that might be good to add to silicon to make your own marker dots or paint that's flexible or hard. Interesting. The paint idea is cool. Someone was suggesting if there is like, actually maybe you will know. Do you know if that retroreflective paint is transparent? Because if it is transparent, that'd be awesome. Because then I can just like get my LED balls and just cover them in this paint, which would be interesting. Like, would that send the light back in towards the ball itself? How would the light get out if it's covered in retroreflective paint? I don't know. But yeah, if it's transparent, that'd be sick, because then I can maintain the color of the ball behindhand. And Ransombot also says, isn't that redundant with the heartbeat stuff you were talking about earlier? This state machine stuff, it's related to the heartbeat processing that I was talking about before, but that heartbeat processing is only being considered in the standby state. So only when we're in standby, like the process here is we have boot, we'll check what's happened before. If this is like a fresh session and we're just starting from scratch, then we'll go into standby. And the whole purpose of standby is just to wait for those heartbeats. As soon as standby has received those heartbeats and it's said, yep, we've got them all, then we move on to the rest of the stuff. And then from that point on, the heartbeats are basically ignored. So maybe that's not the best practice, but that's what I have done right now. Because as far as I'm aware, like those heartbeats don't really contain super necessary information. They do contain the errors, but there's also a separate error messaging thing that's like external, that runs in like parallel to the heartbeat. So I'm getting the errors anyway. I don't need the heartbeat for the errors, and I can't think of anything else that I would really need from the heartbeats. So I'm basically just ignoring them after we leave standby. Hopefully that kind of answers your question. Cool. Yep. So now we need to figure out some way to get the information from get these errors that have, so we've got hardware errors. I hit the e-stop, power's gone. We need to get into fault. How do we get the information of those errors to the state machine to then make decisions? Because the way that the state machine is set up is we basically have all of these, let me minimize some things. We basically got all of these different states, and they are all handled individually. And then in main, the way that it normally works is we ignore this. This is my current method. But the way that it normally works is this one, where we basically run the state machine with a given blackboard, and it's just running. It just goes. And what that means is that all of these states, only one of them is running at a time. And it has access to the blackboard, but it's not inherently listening to the blackboard. So I need to set up some method for all of the states to listen to the blackboard and respond accordingly. So if we are in encoder search, but then I realize something's wrong with the robot and I hit the e-stop and we need it to stop, it needs to stop and go straight into fault. Or if we are in idle state and one of the motors starts spazzing out and starts reporting some wacky error, we need that to instantly go into fault. But they don't do this by default. And so I need some way to get the information from the hardware onto the blackboard and then into each state. And this was ChatGPT's suggestion. Well, it was a combined effort, I think, is to have a separate class that runs at the same time as the state machine. So this is what is going on here. So we basically run the state machine once. And I would, if what I describe here is wrong, I would love if someone could correct me. I'm not super confident in my understanding of this. But what I do understand is that this basically runs each of these things one time. And we run the state machine for one iteration, one operation, and then we update the state. And the way that this works is we go to our robot state sync and we look at the blackboard and we look at the topic of the robot state topic, and we say, are these the same, or has there been an update from some external source? Has some error been reported by some node that I am not currently aware of? If that is the case, then we update the blackboard to say, hey, there's an error here. This is like a brief description of what the error is. And then what I haven't implemented yet is some way for each of these individual states to be listening to that blackboard message, like the error field of the blackboard. Yes, so this is the somehow bit. This is what we're up to. We need some way for each state to listen to the blackboard. And I think that there is a few ways of doing this. One approach would be to have all of the different states be listening in the same way, so that if there's a particular error, like I hit the e-stop, all of the states will behave in identical ways and say, e-stop is hit, we're going to fault. But that seems fine for all of the errors I can think of right now, but I think it's not impossible that there will be errors in the future where I don't want all of the states to behave the same way. Maybe one of the states later on has the robot moving around in some crazy way, and I don't want it to go straight to fault. I might want it to instead go to center the robot in a collected fashion. Rather than just turning off wherever you happen to be, maybe we should try moving the platform into a more kind of stable position before we turn everything off. Because there are absolutely poses. I can move the platform into a spot where if I let it go, things will probably break. And there is a possibility that the robot could find itself in that position when some other error happens, and then if it just cuts off the power to the motors, it will collapse and things might break. So we obviously don't want that to happen. So I kind of want a little bit more nuance to how each of the states will be handling these errors. And so what ChatGPT has suggested is to make a wrapper for the execute function of these states. So each state in here, let me put me back. If we look at the service state, which I now have implemented, which is pretty cool, each of these states has, down the bottom, this execute function. And this basically runs the state for like one pulse, one operation. And this does important things. So I don't want to be fucking around with this execute function. I don't want to modify this at this level, because this means that every single other server state or monitor state or whatever I have, all of them are going to be behaving the exact same way. And I don't really want that, and I also don't really understand the implications of modifying this. I'm very worried that if I mess around with this, then it's going to have run-on effects. It's just going to like make the whole state machine kind of crap itself. So I don't want to touch this code in here, despite the fact that I said that I did earlier. But that was just for troubleshooting. Instead, what ChatGPT is suggesting is that I make a wrapper for that execute function, and then that way I can add in whatever code I want to into that wrapper, and then every time the execute function is called, it will call my code first, and then the actual execute function, and then it will go off to do whatever it wants to do. I've never used wrappers before, is my hesitation. This is super recent. This was like last night that I was working on this. And so I haven't had a chance to implement it. It looks legit. I've heard about wrappers, but I've never actually used one. And I don't know if this is like a good way to do this. I don't really understand how wrappers properly work yet, but this seems like a good approach, because this way I can have like a wrapper for each individual state that I've got with different conditions. So that way we can have that nuance that I described before, where if it's in some weird pose, it will correct itself before shutting everything off. But of course it depends on what the error is. If all of the motors are like, if all of them are spazzing out, then trying to move the robot back might not actually work. So yeah, there's going to be a lot of, I don't know, precision, or like, I don't know, trial and error, I guess, troubleshooting to get all this working nicely. But I think this seems like a good future-proof approach for me to like expand into. Yes, and then depending on what the error is, we advance to the next state. Yes, very, very importantly, which, I don't know, I said this in a different order, but I really want Jugglebot to be able to recover from an e-stop. I would love to be able to just whack the e-stop if some error came up, fix the error, undo the e-stop, and then just continue going. That would be so nice. Yeah, it's gonna be good. All right, comments. RansomBot says, there are glass beads you can add to any paint you want. That is cool. It will pick up whatever color the paint is. The paint needs to be thin. That's super cool. Would you, if you happen to have any links or anything, could you share them? I've had, it seems like the sort of thing that I could probably find online, but there have been quite a few times where people have suggested things, and I'm like, that's a great idea, and I try to find it myself, and I'm like, using the search terms that have been provided to me, I just cannot find what you're describing. But yeah, so if you have any links, that'd be very cool. It sounds very interesting. Thank you, RansomBot. Cool. Okay, next thing. We are very close. We are very quickly approaching the time when I will be able to control Jugglebot, moving it around, probably with a space mouse at first, with this state machine architecture, which is obviously the goal. We need Jugglebot to be able to move around. But my uncertainty is that I'm not too sure how to designate this control. We only want one node, one ROS node, to like one high level ROS node at least, to be controlling the robot at any given time. I don't want to be able to move it with the space mouse while it's trying to juggle. That's not going to end well. And similarly, I don't want to be able to control it with the GUI while I'm controlling it with the space mouse. So only one thing should be running at a time. We've got a couple options here, just like off the top of my head, space mouse, GUI, and pattern. And some of these, importantly, care about things that other high-level nodes don't care about. So like the space mouse and the GUI, they don't care if the platform's level. They're just going to move around, move the platform to where it thinks is the correct spot, and it may not be completely level. The whole thing could be on a massive angle, and it will just move them according to that local coordinate system. But the pattern control, or the juggling, more importantly, it absolutely cares if the platform is level. If it hasn't been leveled, then juggling is not going to work, because we could be at an angle and the ball's just going to fly off to the side. So yeah, I'm not too sure how to manage this control. I can think of a couple different ideas, and I would love some suggestions if anyone has any. One option is to add a field of the controlling node to the state message that I showed before, to this one. So that in this, on this topic, the robot state topic, we just have another thing that says, like, I don't bother typing it in, but we have something that basically says, this node is responsible for controlling the robot right now. And then in each of these nodes here, we basically have a check that says, is this field of the topic showing that I should be in control right now? If that's the case, then continue. I'll do whatever I need to do to control the robot. If that's not the case, and if I'm like the GUI control node, and it's actually the space mouse control node that's responsible for moving the robot around, I will just sit back and relax and not do anything. That's one option. That seems legit to me. That's very similar to how I was doing this before, where I basically just had like a flag that said, is like which node is responsible for controlling the robot. And that seemed to work. It didn't really have any issues, but I'm not sure. There's other options now. Now that we've got this state machine in the background, there's other options that have been introduced, and I don't really know which one's better or worse. So a second option would be for each state in the state machine to only broadcast to its control node. So with this first approach, I am thinking that whatever is like sending the commands out to actually control the robot would be broadcast to all of the nodes, and they all receive it and they can all handle it the way that they want. But with a second approach, there's an individual topic for each control method, and when we are in the state of like space mouse control, only the space mouse control topic will be active, and then only the space mouse node will be listening to that topic, and so it will just respond to that topic because it's getting messages now. So I don't know. I don't know which one's better. Maybe doing both is good, like have some redundancy. I'm not sure. I don't know how to like give control to only a specific node at a time to make sure that there can't be like conflicting commands. Yeah, as I said, any input is very much appreciated. Cool, so RansomBot says, the wrapper idea is good, might add in a confidence level, that way when you send commands or exceed a set time it requires an update, keep the bus quiet. Yeah, I do like that. And also make it refresh when doing questionable actions. Yes, there are, as I've been working through this, I've been realizing that there are so many weird, I've been trying to like really think of like edge cases, and there are so many strange edge cases that can happen. Like this, what happened before, where we ask the teensy what happened in the last session, and it says we finished homing, but we didn't do the encoder search. It's like, if the robot were conscious and it received that, it'd be like, huh? Like, how did that happen? It's like saying I have food in my stomach, but I didn't eat. Like, how did it get there? You know? Yeah, and I know there are so many of these cases, and I don't even know if it's worth like handling all of them, because they shouldn't happen. Like once I fix whatever this bug is that's making that overwrite, this will never actually happen. And even if it does happen, like how do we respond to that? Because right now the response, it checks the encoder search first. And so it says, okay, we've homed, sure, I don't know if I believe you, Teensy, but all right, you say so. But you also say that we haven't done the encoder search, so we need to do the encoder search first. And then as soon as the encoder search is done, we don't check the Teensy result anymore after that first check. So as soon as we head into the encoder search, then we just home automatically anyway. So even though this data is like, I don't know, conflicting, it's still handled in like the best way that it could possibly be handled, where it goes through the whole process. I don't even know if it's really worth worrying about this sort of stuff. I don't know. I'm sure there are plenty of cases where like it could be reversed, where it does the first thing and then like skips the second one because it got the wrong feedback. I don't know. This software, I've been really realizing software is nuts. Like you can go absolutely crazy with abstracting in software, and it's very, very cool, but it's also it starts building up and up and up, and it becomes very difficult to like keep track of what's going on. One very good example of this is I have GitHub Copilot, and usually it's really good at being like, you can start typing some stuff in, or like let's say I want to like add a new variable. I'll go to the top of my like class, my init function, and I'll add in the variable up there, and then I'll go down to whatever method wanted to use that variable, and I'll start typing, and it goes, yep, you probably want to introduce this variable that you just created, and you want to add it in here because this is a sensible spot to add it. So I'm just going to fill that in for you. And normally that's really, really good. But my my CAN interface code, I think especially because I've been adding in a lot of comments and like type hints and this sort of thing, this code is long now. It is 1600 lines long, and GitHub Copilot is having a really hard time with knowing everything in here. So its helpfulness is starting to decrease, which is kind of worrying for me because I've been using it a lot. So I don't know, maybe this is good though. It's kind of like, as the code gets longer, it slowly gets worse, and I hopefully slowly get better. Maybe. Yep. We'll see. Cool. Yeah. Damn, that was an hour. Yeah, I said last week that it's easy to describe what happens in a week of coding in like 20 minutes, but I've been thinking that to get the most useful help out of everyone watching, I'm trying to be as specific as I possibly can be, and of course adding specificity, adding details really extends the duration of these sessions. But I think it's good. Hopefully there will be some, I mean there already have been from Ransomware, some very useful suggestions so far, so definitely worth it. Yeah, cool. As always, all of the code has been freshly updated to GitHub. The link is in the description. Yeah, so check it out if you want to. And if you have any like big comments, post on Zulip. If you have any little comments, YouTube is perfectly fine for that. Yeah, I think that's everything. I'm still waiting on my juggling balls from the Russian balls. John has bought a bunch and he's already arrived. He's already received them, which is frustrating. Bloody Americans and Europeans being fairly close together. Yep, but we'll get there. Cool. Good luck with everything you're doing. Until I next see you. We should have a stream next week. I don't see why we wouldn't. Hopefully we'll have some cool State Machine updates then. It's coming together. I'm very keen. So keen for Mocap. Partner juggling with the robot is going to be incredible. Cool. Alright. Till next week. Have a good one.